Welcome to another video of Corpnce. I'm Rono Savio, and in this video we'll be discussing on time complexity and how you can actually judge your code based on how effective it is with the concepts of time complexity. So let's dive in. Let's talk about time complexity. What is time complexity? Why do we need it? So whenever you're trying to code, as a coder, you might be you have a particular question and you're trying to find an answer, and you see that you have a number of solutions for a particular problem. But now the question is, which one is efficient? Which one do you choose? Okay, now whenever the input is smaller, every code looks similar, like everything is working fine. Every approach seems very right. But increase the number of inputs that you give to your code. Let's say the input was just 100, now we increase it to 10,000. What about a million, a billion? Will your code still be efficient as it was when it was having lesser number of input? This is where time complexity comes into play, and it will make sure that even though your input that you're giving to a particular code is larger, your code is going to work efficiently. So how does time complexity help us categorize that? So we'll see that now. Time complexity doesn't care about your system specifications. Like, it doesn't matter what hardware or system you're using. It mainly focuses on the operations that is being performed in your code. So I'll show an example. Here I'm going to say a for loop. So for I in range, I'm saying n, and n is going to be the number of operations that I'm going to perform. So n, for time being, I'm keeping 10. I'm saying keep the count of the operations that I'm going to perform. So I'm saying C plus equals 1, and C will be 0. Now here print the number of operations performed is, just keeping it more simple for you guys, and yeah, I'll keep it C. And in this particular code, you can see that I'm using a for loop, a simple for loop, and the for loop is going to iterate through the range n. N is 10 at the moment, and this n is the one that is increasing your operation. So when I'm keeping 10, that there is 10 operations performed by this particular code. If I'm keeping this 100, it is performing 100 operations. If I'm keeping it 1000 or 10,000, you can see 10,000 operations are performed. Now your particular code is only focused on the operations that you are performing. So if the operation doubles, then your time increases, obviously. So you don't actually see how the execution time works according to your system taking the time. You literally see how many operations are there to perform by your code, and that particular thing is taken as your time complexity. So here, this one, you are taking n here, so this is known as order of n. So there is a big O notation, and we check the order of n. We take order of n here because n is the one that is increasing the operations here. Now I'm using one for loop, so you're having one order of n. So now you can also have order of n squared. So how is that possible? So if at all you have a for loop, a nested for loop, so for j in range again n, now this literally shows that you are performing two operations at the same time, right? So this will double the operations. We'll see how many operations are performed now. You can see how my system started slowing down, and yeah, that's because there is a lot of operations, and I think I'll just interrupt it because the reason is 10,000 is a lot. I'll keep it 100 for the time being, and you see we have performed 10,100 operations because of this order of n squared. And if at all you have a nested for loop, it can go to n cube and so on. So that is how it goes. Also check this out. If at all you have a for loop separately, okay, now you have a for loop separately. Let's say it's not a nested for loop here. You have a for loop, so like say for I in range whatever n, I forgot n, okay, so for I in range n and pass, something like this. Now this particular for loop is in order of n, and the other one, the top one, the nested for loops, they are in the order of n squared. And when you are checking out the time complexity, you can ignore the smaller time complexity ones. Like order of n is smaller compared to order of n squared. So this one is more hectic compared to order of n, which is the only single for loops. And whenever you are representing the time complexity, you always represent the greater one. So here in this code, you will represent it as order of n squared, not order of n. So yeah, that's what it is. Next one we'll see order of 1, which is known as the constant. I'll show you that too. So when you're saying your time complexity is in order of 1, it means that you're performing a fixed number of operations throughout. No matter whatever is happening in your code, the operations that is needed to be performed is fixed. It doesn't change. And I'll show an example. So let's say you have a list here. I'll say a list of range. Let's keep it 10,000, or we'll keep it 1,000. It's okay. And here we have a list with 1,000 values inside it. Fine. And then I'm trying to access random, what do you say, value here, a of 0. Fine. Okay, random it is, a of 10. Fine. You see that I'm performing just one operation here. Okay, if you count the first line, okay, 2 operations overall, and this stays fixed throughout. This is what order of 1 means. It does not mean that you are performing just one operation. It doesn't circular that one. It means that you are performing maybe 2 or more operations, but it means you are fixed. No matter what you are giving, maybe the input can vary a lot, but still your order is in 1. So order of 1 means your operations are constant. So here is an example for this one, and if you compare it with the for loop one, your order of n was changing. So n is something which keeps on doubling. If at all it increases, your operations also increase. It doubles. That's what. But in order of 1, your operations are fixed, so your code is efficient overall. So order of 1 is the most efficient one for time complexity.